Hello everyone, so today we are solving this problem, height of binary tree after subtree removal queries. So let's read the question. You are given the root of a binary tree with n nodes and each node is assigned a unique value from 1 to n. You are also given an array queries of size m. Okay, so you have to perform m independent queries on the tree where ith query you do the following. Okay, so what we have to do is let's understand. We are given an array binary tree like this, which is numbered from 1 2 3 4 5 like that, and we are also given an m size queries array. Okay, so we have to perform these queries. So what does this query means is so the query means is remove the subtree rooted at the node with the value queries I from the tree. So first of all we have to remove the node at the query I values. Okay, and it is guaranteed that query I will not be equal to the value of the root, means the entire node is not gonna delete it. So what we have to do, return an answer of size m where answer I is the height of the tree after performing the ith query. So it is like this. So this is our binary tree bt, and what we have to do is these are our queries. So for example this is 2, so we have to go to the node which having value 2, like this guy. So we will come to this guy, and after reaching to that guy, what we have to do is basically we have to delete this guy. Okay, so we will delete. So what would be the height of it? So we will put that height here. So for example, if we delete 2, if we delete this guy, what would be the height? The height would be, so basically the height of initially of this tree is like this. This is the biggest height, right? But the root that gonna be delete is 2, which is not the part of this path. So in this case, what would be the height? How it would be the 1 2 3. So there are 3 edges, so this would be coming here 3 like this. Now come to 6. If we delete 6, this guy is also not the path in the path of this the biggest height, right? So at the 6th place also it would be 3 only. But when it comes to the 4, what will happen? We will delete this entire array, entire tree, right, under the 4 node. Okay, so if we delete this, what would be the height? This would be our remaining tree, and the remaining tree would have the height 2. So for 4 it would be 2. So basically we have to do this removal operation, and what would be the height of it? We have to put that height. So and also so after doing this, there are certain nodes that are given to us. The queries are independent, so the tree returns its initial state after each query. So after every query it would return back to its initial state. Okay, it's not like it would be updated. Like if we do here, if we update, for example, if I remove this guy 4 node, right, if we remove this all, then next query it would be as it is. Okay, so you can consider it whenever we are going to the next query, it would be its initial state, right? So this is what they are saying here in this note. And one more thing is, height of a tree is the number of edges in the longest simple path. Okay, so for example here you can take this example. Here this is the biggest height because there are 3 edges. Longest height is 3 edges. So this would be the 3 is the height of it. Okay, so this is what we have to do. Okay, so let's do one example for this. For example, if we do this solution for this, what would be the solution of it? So we can do that easily. So as you guys know, if we delete 2, if we remove this guy, this is still the highest path, right? For this guy, this is our still highest path. So even if we are removing 2, what would be the height? Height would be still 3. There are 3 edges, so this would be 3. Now for the next query, everything would be come to the initial state. Okay, so we cannot consider that this is still a modified tree. The tree would be come to its initial state for every new query. Okay, so what will happen now? Next is 6, right? So if we remove 6, what would be the height? If we remove this 6, still this path is the biggest height, right? Because we are not deleting anything from this path. So still the height would be 3, remains unchanged. Now come to 4. What if I delete 4 itself? So if I delete 4 itself, what will happen? This entire thing would be gone for this query time being, right? So this entire thing would be gone. Then what would be the height of remaining tree? It is basically 2 only, right? We have only this portion. we have only this portion which is of having height 2. So we have to return 2 here. So this would be our answer. This is what we have to do. Okay. So now we will discuss about how to do this. So guys, suppose I have taken a different example here. This is our binary tree. Okay. Now suppose we can observe one thing. So at every level, for example, go to this level. Okay. What is the depth here? What is the depth of this guy? Depth of this guy would be 1, 2, 3, 4, 5. 5 is the depth of root node, right? Now come to this level. We are going level wise. So what is the depth here? Maximum depth of 2. It is 4, right? This is according to this line. This is the 4. And what is the second maximum depth? This is the second maximum depth at level 1, right? So this is giving us 4 and second maximum is 3, right? Similarly, go to this guy. What is the maximum depth here? 4 is having this guy, 3 is the maximum depth, and this guy 6 is leading to the second maximum depth, which is 2, right? So every level, what we can do is at every level we can find the maximum depth and second maximum depth. I will tell you why. Okay, so for example, now let's say we have got here 2 and 3. So obviously 2 is leading to the maximum depth, which is 4, and 3 is leading to the second maximum depth, which is 3. Now suppose we are deleting one of them. Now let's say if we store this information, the maximum depth and second maximum depth at every level. Now suppose we're gonna delete this guy 2, right? So if we delete 2, this guy has the depth equal to maximum depth. In that case, our second maximum depth should give us the maximum depth in that case, because if we delete this, then this would be the depth of it, correct? So we can use this utility in our solution. Okay, so how we will be using this, I'll tell you. So first of all, what we will do is like for this thing we will do the dry run of it. Okay, so let's say we are starting with this. So this is our max 1, this is our max 2. So in max 1, okay, this is our max 1 and this is our max 2, let's say. So for 0th level, so 0th level, what is the depth? Depth is 5, right? So this is our 5. Even the second max is also 5 there, because only there is one node, right, at level this level. Now come to this guy in the second level. So 2 is leading to basically the maximum depth, which is 4, right? And what is the second maximum depth? Second maximum, it is 3, right? So it is 3. So we are writing it. So these are the level wise. So this is 0th level, this is 1 level, right? Then we'll go to the 3rd level. So in 3rd level, what is the maximum depth? Maximum depth is this guy 4, 8, 10, right? So this is 3. So we are writing in maximum, and the second maximum will come to the second array. So second maximum is the 2, 6 and 9, right? So it would be 2 here. Now come to this level. What is the maximum depth? Maximum depth is 2, right? 8 is leading to 8 and 10. So this will come here. So maximum depth is going to the first array. So this is 2, and the second maximum depth, which is leading to 1 only. Okay. So now this is our final one, 10, right? So 10 has 1 and 1 only, right? So this would be 1 and 1. Now guys, we have recorded the maximum and second maximum depth. Okay. Now what we're gonna do is whatever we're gonna delete. Okay, let's say value 5. So if we go to value 5, this we will store also for every value their corresponding level. Okay, so we will store the level as well. Okay, so we can have a level array like this, and what we will do is we will store basically the level array. Okay, so whatever is the value, its corresponding label we would be storing. Okay, so for example, if we come to this guy 5, in our query it is 5. So immediately, first of all, we have to find in level array what is the label of it. So we will get the label equal to here 2, right? 0, 1 and 2. 2 is the label. So then we will find, after finding the label, we will go for this node, right? This is our node. Anyway, this node is already there. So for this node, what we will do, we will basically get the depth of this. Okay. So we want to get the depth of this guy 5. So now what we have to do, after let's say depth is D, Let's say depth is d, and we have found already the level of it. Now we will check in the max 1 and max 2. Okay, so if this depth is basically equal to the maximum 1. Okay, if depth is equal to maximum 1, then second maximum should be our answer. Okay, and if the maximum if this depth is not the maximum 1, then anyway the maximum 1 would be the answer. So let's take one example to make it more clear. Okay, so for example, we are deleting 5 itself. Okay, so what is the label? Label is the 0 1 2. 2 is the label. So first of all, we have to find what is the depth of this guy, 5. Its depth is basically 1. Okay, so and what is the maximum depth here at this level? This is 2 level, right? So we will come to here. This is the level 2. So 3 is the maximum here and 2 is the second maximum. But this guy is d is equal to 1. So anyway, we have to give the 3 as the depth of that level, right? So what we will do is our answer would be 3 is the depth plus whatever is the level. Level is the 2 minus 1. Correct? So this would be our 4. 4 should be our answer. Okay, because you can now confirm itself. Let's say I am deleting this 5. So what is the height? Height is still our 4 only. These are the number of edges, basically the height. So there are 4 edges only. Correct? So with this help we can do it. Let's take one more example. Okay, I'm just putting it back. 5 was there. Now suppose we gonna delete 4 itself. Okay, so what we will do, first of all, we will get the level of it. So what would be the level of 4? Level of 4 is basically 2 only from the level array that we have stored. Now what would be the depth of this guy? Okay, so depth of this guy, what will be the depth of this guy? If I wanna delete this guy, if I want to delete this is the level equal to 2, and depth of it is what it is depth is 3. Correct? Now I will check at this level, at level 2, that hey, what is the maximum depth here? So maximum depth here, it is 3 only. That means the guy which we gonna delete is the guy who is leading to the maximum depth. So if we delete this guy, the depth should be at this level. The maximum depth would be now the second maximum one, right? Now this guy, if I delete this guy, everything would be, this portion would be deleted. So in this case, this guy would be lead to the maximum depth, means the second maximum one. So this guy, this 2 would be our maximum depth in that case. So what would be our answer? Our answer would go like this, that whatever the depth of it, basically, so in this case what it was basically going to the equal to the maximum depth, right? It was equal to 3. If I go to 4, if I delete this 4, this will basically remove the maximum depth because it is leading to the maximum depth. Then it's our second maximum depth, which is 2, right? This 2. So second maximum depth would be come to the picture. So what it would be, second maximum depth 2 plus whatever the level of it, which is 2, and minus 1. So 3 would be now our height if we delete the node number 4. You can visualize as well. If I delete this portion, what would be the height? You can visualize it clearly. The new height would be this guy, 1 2 3, right? So this would be our approach. Okay, I am just putting it back. Now we will take one more scenario. Let's say we are deleting the node number 6. Okay, so if we delete node number 6, first of all we will get the level of it, which is again level is still 2, right? So level would be still 2. And what is the depth of this guy? Depth of 6, basically it is 2, right? And at this level, what is the maximum depth? Maximum depth is 3. So that means if we are not deleting a node which is leading to the maximum depth, that means our maximum depth would be still this guy, 3, right? So what will be answer? We will take 3 plus whatever is the level 2 minus 1, which is equal to 4. You can visualize as well. If I delete 6, everything below it would be deleted, but our height is still 4. See here, our height is still 4. You can check it clearly. This guy is not affected. Our height is still 4. So this would be our approach. Now you should be very clear. So let me show you my corresponding code for it. See here, this is our code. Now what we are doing here is, like, I have declared 4 variables. Okay, this depth is the one which will store the depth of every node. Means depth is something like below it, how deep it is going. Okay, and this is the label array, which is basically storing the every values corresponding label. And maximum 1 and maximum 2, these are the array which are storing the maximum depth at any level and the second maximum depth and at every level, like we were doing here, right? So same way we are gonna do that. Now see here what is happening here. These are the maximum 1 and maximum 2, the maximum value at every level, and maximum 2 is the second maximum value at every level. Just we did, right? At this level, for example, at this level, this was our maximum depth, which is 3, and this was our second maximum depth, which is 2, from starting 6 to 9, right? So that thing we have to store. So maximum 1 and maximum 2 at every level. Now what we are doing, I have written one height function. Okay, so what it is taking is, it is taking root and the label. So we are passing the label. So see here, if root is null, anyway we are returning 0. Otherwise what we are doing, in the label array we are putting the information here that, hey, label array of root dot value. Okay, so root dot value is basically taking the value sitting at this label. Okay, so root dot value equal to label. So we have put the values corresponding label here. Okay, now you might have a question that, hey, what is the length of this label array? So its length we have taken, right? Its label length we have taken it 10 to the power 5, right? Because it's given in the question that this value would not go beyond this. See here, 10 to the power 5 values, right? So for that reason I have taken it this length. Now we have put the corresponding label of this value. Okay, now depth, you know, the depth of root dot val. Okay, the depth of it any would be the 1 plus whatever the maximum height for the left child and right child of it at the next level, down level, correct? That would be the depth of it. You can visualize it here. For example, we want to take the height of this 3. We want to take the depth of this 3, right? So we will take the height of this level, height of 6 left child and height of right child. Okay, so 1 plus height of level plus 1 guy, left child and right child. We will pass here whatever level L here, then we pass here in height function L plus 1 and L plus 1. Whoever is giving maximum value, that should be the depth of this guy, depth of this guy. So same thing what I am doing here is like depth of root dot val equal to 1 plus maximum of height of root dot left at level plus 1, anyway, because left guy child guy would be go to level plus 1 only, right? And the right and level plus 1. So whoever is giving us the greater height, that thing would be stored in depth root dot value. Okay, and you observe here at every function, this height function basically it is also populating the label of every value. Okay, so when we will call here, this internally would be update this array. Okay, now after coming till here, we have got the depth of whatever value we are currently encountering, correct? We have stored this depth of root dot val. Now what we gonna do here is basically, first of all, we are checking that, hey, is the depth of it is greater than the maximum depth occurred on this level. So if this is the maximum, if this is greater than the maximum itself, then anyway we have to update it, right? Because maximum value now would be equal to this guy, maximum 1. So second maximum would be now the previous value of maximum. So nothing, just we are swapping these values so that the maximum would be the greatest value and second maximum would be the previous max. Okay, so after doing this we have updated. Okay, because we are going to every level, we got the depth here. So we are doing a single traversal all these things. That is why we are going for this memoization approach. So if this is not smaller than the maximum one, then let's check, hey, is it greater than at least the second maximum one? If it is greater, then we will update the second maximum one. Okay, so only these two conditions are matching, then we gonna update, and finally we are returning the depth of it. Okay, so this is what in the height function we are doing. Now after doing this, what is happening? We are calling this function. So see, these are my array which I just explained, all these array of these 1401, right? So 10 to the power 5, correct? So we are calling this function at height, root and 0. So I am passing here level 0. So when this further being called, this recursive function, it would be update to the level of all those values who are encountering here. See here at this line. So we are further going deeper. Okay, so this thing would be automatically updated because calls are happening inside it. Now after doing this, when this height function we are coming out of it, everything in these values would have been updated, all these 4 arrays wherever it is required. So now what we're gonna do is, like, we are now traversing through this queries array, right? We have the queries like this, these are the queries array. So we're gonna go inside this queries. So see here, whatever query we are taking, first of all we are getting the label of it. Okay, so label array would give us the corresponding label. Okay, now what we are doing here, at depth q we can get the depth of it. Okay, so now here we are checking that, hey, the depth of this query is equal to the maximum depth at that level. If let's say it is equal to the maximum depth, in that case we are returning the second maximum value at that level, right? Just we did it when we were deleting this guy 4 at this level. So if we delete this guy, then our answer, the depth would be the second maximum, which is leading to this guy 2, right? Starting from here. So that case I have covered here, that hey, if the depth of the query is equal to the maximum depth at that level, then we are returning the second maximum depth. Otherwise, if it is not equal to the maximum one, then anyway we have to return the maximum depth only. Okay, and so depth part is here, and then this is the label plus label minus 1. For example, let's say we are getting the height of any node. For example, we are taking height of this guy. Okay, so what would be the height? If we, so this is the if we take the downward, so this is its level, right? So 1 is the level of it. So 1 plus, and what is the downwards depth? Depth is 4. So 1 plus 4 minus 1. Okay, this is the level. So this would be basically 4. So 4 is the height here. That is what I am doing here. Okay, so we are doing whatever the depth according to whether it is a maximum deleting leg or second one. So and then we are adding plus label and minus 1, because we are we have to deduct one of them, because height is equal to the basically total number of edges. Okay, and so finally we are updating all the queries accordingly, and then finally we are returning this query array. So let me execute my code. I'm executing my code. Okay, so there is some error. Let me try it again. Yeah, so it is 92.28% faster. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.